All right, I will begin with a word of prayer. So here we go. Dear Heavenly Father, we thank you for this day. Thank you for another beautiful day outside, and for these students. Just ask you to bless our work today. Help us to just wrap up our thinking about factoring and give us insight into how to remember all the things that we may have forgotten since it's been a little bit, but just encourage the students, help them do their best, Lord, each day for your glory. In your name I pray, Lord Jesus. Amen. So if you have questions about how to set up the homework, I cannot answer them right now. However, if you want to come to my office hours, I can try to help you. But I will say, key facts, we have to register through Canvas. There is no course code, and those are the central things. Past that, if you get stuck on things, just email me and describe what the problem is, and I can try to help. And I've been successful through email with students about half of the time at the moment, so, there's that. All right, so any questions before on math? Let me just get straight into it. Then I got a bunch of examples to show you today. So example 1. So here we're supposed to factor, if possible. And here it is. We have 5s squared plus 14s plus 8. All right, so we're either supposed to factor it or check the box and say it's prime, right? So let's try to factor it. So with 5 here, I'm going to try something like 5s and put an s over here like that. So what do you think? What should we try? 8. We could factor 8 as what? Like 1 and 8 or 2 times 4, right? Those are your kind of obvious choices here. What do you think we should do? 2 and 4? So if I do plus 2 and plus 4, right? There's no minuses here, so I want pluses. That gives me, if I multiply it out, 2s and 20s. That's 22s. Well, flip them. So put a 4 here and put a 2 here. See, did that work? If we multiply this out, we get 4 plus 2 times 5, which is 10. 10 plus 4? 14. Woohoo! So there you go. This is how we factor this one. So this kind of factoring is what I often refer to as guess and check, right? So there's one. So is this prime? Apparently not, right? We could factor it. So example 2. We're supposed to factor, if possible, again. So I won't copy the instructions down. I'm just going to do the problem here. Same instructions as number 1. So this time we have 12 x cubed plus 10x squared minus 12x. Now, your homework tends to have letters other than x, but I tend to focus on the letter x in my tests in here because that's your happy place. And I don't want the student to get something wrong just because I changed the letter, And there's a subset of you that changing it from x to something else, it actually hurts you, yeah? So anyway, we should be able to see past that, but. So can you guys tell me anything we can factor out here? A 2? All right. A 2 and an x. All right, so let's try that out. 2x. If we factor out 2x, what's left? 6x squared, right? If I take 2x out of 10x squared, I have left 5x. And if I take 2x out of minus 12x, I've got negative 6. Very good. All right, now this is a quadratic, so maybe we can factor it, right? Can we factor that? So let's try it out. Let's see here. I think I'm going to try like 2x here and 3x there and see if that works for me. You could also try like 6 and x, right? if we do 2 and 3, what would we do here? Could we get that? How would we get that 5 in the middle? We need, yep. One is a negative, one's a positive. That's right. Yeah, we're definitely going to have like a plus and a minus, so to speak, or a minus and a plus here. But the question is, what to fill in the blank here, right? Let's just try something, right? Like, how about minus 3 and plus 2? That's one of the things we could try, right? Because minus 3 times 2 gives me minus 6, which is what I need for the constant term here, right? The question is, did it work? So we've got minus 9 plus 2 times 2, which is minus 9 plus 4, which is, oh, it's minus 5. Bummer, right? So we can fix this out? Yeah, we just changed this from minus to plus, and that from plus to minus. I think with that adjustment, then we have it, right? Because we have 3 times 3 is 9, 2 times minus 2 is minus 4, 9 minus 4 is 5. So, right? So again, I'm using the guess and check method, which is, not foolproof, I would say, because every so often we've got a prime polynomial, right? And then no matter how much we guess and check, we're not going to get it. There is a method which is foolproof, which we'll get to in a future class. Example 3. And by the way, that's it. That's as far as you can go, right? You can't factor that further. I mean, you can always factor something further, but this is enough. What I mean you can always factor something further is you can always play games like pulling a number out of it and dividing by that number. For example, if I had 3x plus 7 and I wanted to factor this, I could, right? I could pull a 3 out. How do you pull a 3 out of a 7? So that's 3 times 1/3, right? Three times 1/3 is 1, right? So if I do that, then I have a common 3 here and here. I can pull the 3 out. And of course, this times this is just 7/3. So, like, in that sense, you can factor things, right? And there's a problem or two like that in your homework, actually, right? It's just a linear polynomial that says factor it. They just want you to pull the number out, right? Now this one we haven't done yet, and this one I'm about to do, I think, is interesting. I would just say, if you wanted to study the universe of all possible college algebra tests I've ever given in my life, of which there are many, one of the things you'd learn is that a problem like this is almost always on my test which involves factoring, which in your case would be test 1, right? I'm just checking, see if that stuff's bouncing. It's bad. But we're good. Now here, I've got x to the 4th minus 16. See where you're sitting? There we go. Now you guys aren't battling with the glare on the front board. Okay, so how do we do this one? We have to use our imagination a bit, right? So the way to look at this is that this is x squared minus 4 squared, right? And with that in mind, what did we learn last time? Or remember last time? Remember the pattern? A squared minus b squared is a minus b times a plus b, right? That difference of squares formula. So we can use that here, because it's a difference of squares. We just have to see it. Now that we've seen it, what does it do? We've got x squared minus 4, right? times x squared plus 4. Now, if you don't believe me, just check me. If you multiply that out, do you get back to where you started? Search your heart. It's true. Yeah? Because like x squared times x squared is x to the 4th. Minus 4 times 4 is minus 16. And the cross terms cancel, right? Because we get a minus 4x squared and a plus 4x squared as we FOIL that out. Are we done? Can we factor this more? I think we can, right? Because what is 4? 4 is 2 squared, isn't it? So I can look at this as 2 squared. Yeah? And with that, I can factor that as x minus 2 times x plus 2. How about this x squared plus 4? Can you factor x squared plus 4? You're like, sure. Euler found the imaginary number, a notation for it, I, in like 1777. We've known complex numbers for like, what, 300 years. We ought to be able to factor with complex numbers by now. And yet I've never had this answer in a college algebra class. But like, yeah, you can't factor x squared plus 4 unless you know complex numbers, right? So that's it. That's prime.
Why is it prime?
Why is it prime? We can't factor x squared plus 4. Like x squared plus 4, if you wanted to factor it, here's how you do it. Where this I is the square root of minus 1. Or, in terms of last class, if we look at x squared plus 4, if we look at that as ax squared plus bx plus c, what are a, b, and c? A is 1, b is 0, c is 4. So b squared minus 4ac is what? 0 minus 4 times 1 times 4, which is minus 16, which is less than 0. So by the theorem I shared with you guys day 1, x squared plus 4 is a prime polynomial. Another way to look at that is its factorization involves complex numbers. Yeah. There's nothing about complex numbers yet in your homework. I'm just making this comment for the larger story in the course, all right? That's not tested on yet. So, would you like me to erase the offending complicated part? Okay, there you go. Okay, so that's it. End of story. Right? Would you like to work another one like this?
Yes.
All right. Example 5. Here, how about this? What if I have z to the 4th minus 81? See if you guys can do that one. Can we factor z to the 4th minus 81? So we're going to look at this as z squared squared minus 9 squared. Right? So it's difference of squares. And so we can 9. Oh, by the way, in case you hadn't picked up on it, I guess I should actually say the words out loud. I've written the top hat code over there. See? Top hat. And I think my computer has gone to sleep because my computer is dumb. Or I'm too dumb to fix the computer. At some point, I'm going to go into the power settings and make it so it doesn't keep shutting off on me and annoying halfway through the top hatting. It should come back if it's gone. Is it gone? Is it back?
I think so.
Does everyone put their top hat on? Okay, exciting. Are we done? Well, no, we're not done. See, because z squared minus 9, we can still factor, right? So yeah.
Oh, actually, never mind. Sorry.
Oh, okay. It's all good. Glad I could help. So z minus 3. Isn't that funny? Like sometimes just asking the question fixes it. So there you go. We can do minus 3 plus 3. That multiplies out to be z squared minus 9. And again, the z squared plus 9, that's prime. Anytime you have squared plus something, just that, that's a prime polynomial. Yeah. You say, please, sir, may I have another? Yes, yes, I will oblige. Here we go. Example 6. Ooh. I think this is this marker's final journey right here. So pay it mind. Lived a good life, but this is its end. A plus g quantity squared minus 64. Can we factor this thing? This is an example where you want to think about making a substitution, right? So like, think of this as x squared minus 64. And what did I make x equal to? A plus g, right? So with that substitution, this is x minus 8 times x plus 8, right? Because 64 is 8 times 8. So that's actually difference of squares, again. And then put back in the substitution, you've got a plus g minus 8, a plus g plus 8. I don't usually make it. It's just fun. Yeah, thank you.
Why can't we take this down to 4 and 2?
4 and 2? Well, you could, but it wouldn't work.
Okay.
I mean, because this 64, if I can erase that.
Oh, yeah.
Let's trade that 64 for a 8 squared, right? So recognize your enemy. This is the difference of squares pattern. So we don't need to factor. We just need to apply the difference of squares formula in some sense. Yep.
So is it like, can you not factor anymore because you substituted a?
Can I not factor this anymore?
Yeah.
Yeah, I think that's it. I mean,
Okay.
like, these are both linear in the sense that there's no squares or anything. So like, best thing you could do would be like factor out a number, but that's pretty much it. Yeah. Yeah.
How are you going to change a plus g to x?
Oh, this is just a. So this is just a creative leap. It's a substitution.
What happens if you didn't put x and you sub f for a plus g?
Well, then the question is, can you see the pattern still? So like, sure. Here's another one. Like, what if I had x plus y squared minus 17? Could I factor that? I could without a substitution if I can see it. The question is, can you see it or not? Yeah. So that's the square root of 17 squared. So if I go, oh, wait a minute, that's difference of squares. And I think about a equals x plus y, and b equals the square root of 17. If you see that pattern, so what I'm really what I'm asking is, do you need to write down? Do you need to write down what I wrote over there to make the step I'm making right now? Do you? I mean, yeah, technically no, but it might be helpful for you to see. In the same sense, in this previous problem, do you have to invent the letter x and change it to x? No. If you saw from the outset that, oh, wait a minute, this is just equal to a plus g minus 8 times a plus g plus 8, well then great. Right? You didn't have to go through the step of letting x be that.
So you could do that instead of making it x equals a plus g. It's
Right.
the same thing.
Yes.
Okay, so there's like two ways you can do it. You don't have to do it like that.
Absolutely. Think of the x equals a plus g as like training wheels for a bike. You know, some of you need it, some of you don't. But in your homework, it will say like make a substitution. In some of the problems, it's talking about doing this kind of thing, right? Is the meaning of x fixed here? I've used x in a rather different way here and here, haven't I? So, I mean, here the substitution was a, but anyway. All right, let me shut up about that. Can I close the top hat? Are we all good? I got 37 to 38. It seems like we're done. Everybody here is top hatted? Uh-huh.
So is it, why, I know this sounds, it's probably like a dumb question, but.
Probably not. Uh-huh.
For Z, why does it add up to 6 squared plus 9? Is it because it's,
Why?
in the end, like when
Yeah.
you can't factor anymore, is it because you already have?
Oh, yeah, that's just, so that is just following along.
Oh, okay.
So that appears from the first step, right? Well, like this step right here. So this is literally, again, this A minus B, A plus B pattern, right?
Oh, okay.
Where here A is Z squared and B is 9. And so this is like that in the pattern, and it's just here and here. And everything interesting going from this step to this step is occurring in the first factor.
Oh, that actually makes a lot of sense. Sorry.
Yeah, yeah. No, if you were trying to understand there's something, if you're trying to think of something happening to that second factor, I can see why you'd be confused. Yeah, absolutely. Other questions? Questions are good. We always have time for questions. Yes, sir.
So to go off that, so there's nothing happening to that second factor there? Or is it
Yeah.
thinking of that?
Exactly. And I know I can't do anything to it because it's the same pattern as we saw in example 4, and we already learned that that's prime. So like I know, game over. Nothing to do there. All right, so let me see here where I put my problems. Mathematicians are strange. We're only happy if we have problems, you know? But let's see here. Example 8. Here we have 4 n minus 4 quantity squared plus 20 times n minus 4 plus 25. And we're supposed to factor this if possible. And I'm going to work like this here if you don't mind. I'm of the school of thought here that the substitution is worth making. Like, I don't like to think about this without making the substitution. So what I suggest here is we let x equal what? What do you think? X equals n minus 4. I think that's a good choice. See, because then this becomes what? 4x squared plus 20x plus 25. And then the question is, can you factor that? Yeah, it's a quadratic. So I think we can do something like 2x and 2x. And oh, it just pops out at me. We do plus 5 and plus 5. That's how this is going to factor. See? I did that pretty fast. That might take you 3 minutes on your own. But I just did. Because you'd have to guess and check and sort through it, yeah? But if you check, I think we're right. You see, because I got 10 plus 10 is 20. I get my 25, and I get my 4. We're good. So are we done? We're not done, right? We need to undo the substitution. That's part of the cost of a substitution is once you make it, you have to undo it. So here we got 2 times n minus 4 plus 5, right? And then, well, the same thing again, right? And does that, I think that simplifies a bit, doesn't it? That's 2n.
Why couldn't you just write it the first, like when you factored it, were you just trying to write the steps out, or were you
Yeah.
just taking multiple squared?
Yes, yes. You, at this point, you could have been like, aha, well, this is just 2x plus 5 squared. That's
The n minus 4, just like that.
yeah, and so we have 2n minus 8 plus 5, which is minus 3, so but you're absolutely right. If you had written this squared earlier, then you wouldn't have had to write the substitution twice. It would have saved you a lot of writing, right? That's one of the reasons to use the square notation is it saves you writing things double like I just did. So, yeah.
I knew this might happen too, but when you got the 2 10s, right, that added up to make the 20.
Uh-huh.
Like I'm just kind of lost with it.
Oh, so this is just going from here to here, the factoring?
Yes.
Well, in principle, when we put the 2x and the 2x there, there's a lot of different possibilities, right? We could think about 25 is like 5 times 5 or 1 times 25, or I guess in principle minus 1 times minus 25 or minus 5 times minus 5. But of all those possibilities, I just saw that 5 and 5 works. Also, in principle, this 4x squared you could have split as x and 4x also. I mean, factoring has a lot of cases to think through. I don't know if that answers your question or not, but like ultimately, the question is when I multiply this out, do I get back here? If I do, then I'm right. Yeah? Behind you?
Would you take multiple answers if you were to put that on like a test or a quiz? Like, would you take the second line that we did, like 2x plus 5?
Well, I would want you to undo the substitution. So the answer should be in terms of like the letter n, because the letter of x was just like kind of a scratch work in between thing, yeah?
Okay.
Uh-huh.
And then another thing, if you had like other variables, like if you had, I don't know, y minus like 3, would you be able to substitute that for x, or can you only do that for like certain problems? Like when you substituted like n minus 4 equals x,
Yeah.
would you be able to use that type of formula for other problems or solving?
I think that's pretty much just applying to this problem. Yeah.
Okay.
There's no like universal x equals n minus 4.
Like that, I think
Yeah.
like, if you had a different problem with like different variables, would you be able to substitute it for x in other problems too, or is it?
Yeah, I think so. I mean, that's more or less what I, like that's kind of what I did here, right? I had x and y and I traded it for an a. I mean, yeah. I have to be careful when I agree to students' questions because I may be signing up for something I don't believe in. Yes?
On tests, are we going to have to, like, for example, we have to take 2n minus 3 squared and you take it back up?
Bless you.
The top of 4n minus 4, and, like, completely the opposite of what we're doing.
Oh, like multiply this out?
Yes. We have to do that on the test, or is it all
I mean, it is something you need to be able to do, but yeah.
So really fast. So if you were to do like the 2n minus 3.
It's possible. Yeah.
If you were to go back in and like solve 2n minus 3 squared, would you accept that as an answer too? If we accidentally went too far, unfactored it on accident, I do all the time.
If you multiplied this back out,
Yeah, but it would like not all the way back out to get up to the factored point, but to the 2n minus 3 squared. Like you actually multiplied 2n minus 3 and then.
you mean like multiplied this out and put it
Yes.
in standard form? Well, that wouldn't be factored, right? That would be something else. There is an alternate question you could ask, which is to put f of n into so-called standard form. Now I'm really getting off track here. Put f of n into standard form. I'm going to give this a label f of n for the sake of writing it. All right. And then if I was to ask that question, which has not been asked in your current homework, because that's a question about multiplying polynomials out, then you'd have to, like, n minus 4 squared is n squared minus 16n plus 16, and then plus 20 times n minus 4 plus 25, which would be 4n squared minus 64n minus 60 plus 64 plus 20n minus 80 plus 25, which would be 4n squared minus 44n. What's 85? It's 64 plus 25 is 89. 89 minus 80, I think is 9. So if I haven't made a mistake here, which is questionable, there you go. Multiply it out and put it in standard form. There would be the answer. But that was not the question asked.
That's not the question asked.
That would be a different question from. Anyway. All right. Let me move on. So now I'm moving on to rational expressions. Okay, so example for today, 9. This one is going to be nice relative to what we've been doing. How about this? 15x to the 8th over 7 multiplied by 21 divided by 10x. How would that go? So what's the rule? So you can like put all the numbers out front, right? We've got 15 times 21 over 7. What is 21? 21 is 3 times 7, right? And then you've got x to the 8th over x, right? I lost my 10, didn't I? 10 is what?
2 and 5.
Yeah, so sorry guys, let me if you'll allow me this mulligan. So part of doing good math is writing the thing that's helpful to you the first time. So like 15 is 3 times 5. 21 is 3 times 7, right? 7 is 7. 10 is 2 times 5, right? And then I have x to the 8th over x. So if I look at it this way, it makes the problem relatively easy because I can identify which prime factors are common and I can just cancel them, right? Like 7 cancels 7, 5 reduces with 5. We got 3 times 3, which is 9. So we get 9 over 2 times x to the what? X to the 7th. So x to the 8th over x is x to the 7th. There you go. Now, you're like, how do you know how to factor the primes and stuff? Well, you don't have to, right? You guys are allowed a scientific calculator. You could just take your handy-dandy calculator out and go 15 times 21 divided by 7, and then divide by 10, and my calculator says 9/2.
Could you just take 15
Right.
times 21 divided by 70?
Yeah, you could also do that. He said, could you just take 15 times 21 and divide by 70? Hey, thank you. Did I do that? Did I do that?
No, I did that.
Oh, thank you, thank you. Sorry. I had to give credit where credit's due. Okay, so you guys don't usually have much trouble with these kind of ones, right? It's not too bad. And you also will not have trouble with the next example, I don't think. So we have 5, bless you, x plus 5 minus 3 over x plus 5. So can we subtract these? Yeah. So we get 5 minus 3 over x plus 5, 2 over x plus 5. So let's try a different one. What if we had 5 over x plus 5 minus, oh wait a minute, I'm sorry, my bad. Oh, what am I doing? I used the smudger. X plus 5 over 5 minus x plus 5 over 3. How would you do that one?
You'd have to have
And
then you have to multiply the other side by the.
Here, how about this? I do 1/5 minus 1/3, and I factor out x plus 5. Yeah? Would this be okay? So that's one way you could do it. You can also make a common denominator. So some of you guys are telling me, multiply the first one by 3, multiply the second one by 5, then you got a denominator of 15. You could do that too, sure. This will work. This is, so 1/5 minus, that's 3/15 minus 5/15, so it's, minus 2/15 times x plus 5 would be this one. All right. So there's a bunch of questions in the rational expressions homework that asks you about domain. So what's the domain of an why haven't we talked about domain yet? Why at no point have I said, hey, what's the domain of these polynomials, the quadratics or the linear ones or the cubics or the quartics, fourth order, right? Why didn't I ask you about domain in any of these? Because it's like kind of boring, right? The domain is everything because like you can put any number you want and add it, square it, cube it, take it to the 4th power, fine. But when we start talking about division, that's where we have to be careful, right? Because you can't divide by what? 0, right? So we're on example 12. So here we're supposed to find the domain of rational expression. So here's the expression, x plus 3 over x minus 4, right? And what's the domain of this thing? What can we not have?
4.
Right, we need 4, right, exactly. We need need x not equal to 4, right? So that means that the domain is equal to x such that x is not equal to 4. So this is called set builder or roster notation that I just used, right? This is set theoretic notation. If you wanted to write it in terms of like intervals, the number line, it's a little bit more complicated. It looks like this. Minus infinity to 4, unioned with 4 to infinity. So this right here is interval notation, right? And I don't think your homework even asks you about that, so that's just a...
On a test, would you not care which way we wrote it?
I will eventually want you to learn interval notation, but
Okay.
we'll do more of it when it happens. So I'm just mentioning it here. Another example, I think in your homework, though, you don't have to do the interval notation. It just has like x not equal to, it allows you to phrase the answer like this, like the first way I did it. Yeah, yeah. Now, I mean, if I say find the domain of the rational expression, and you just tell me, well, x is not equal to 4, I'm going to give you full credit because that's the answer, right? So you didn't write it this way. That would just be kind of mean on my part in here. Now, if I say find the set, which is the domain, if the wording is very particular and I say I want the set, please use, then I would like the answer to be a set, right? But even if I said give the answer as a set, if you put the answer as x not equal to 4, I would still give you like a lot of partial credit, like a lot. Anyway, so here, what's the domain of this expression? We need what? We need x not equal to 7. I'll do the easy part. And what's the trouble for 8x plus 2? Yeah, if we put 8x plus 2 equal to 0, that's the trouble, right? Don't want this, right? Solve that, you get what? X equal to minus 2 over 8, and that gives me minus a quarter. So the domain, x such that x is not equal to 7 or minus 4. Yep.
Why do you have like a line in it?
Ah, yes. So here we could do like students such that went to Convo. So this would be the set of students that went to convocation, right? So like you put the universe of things that you're looking at here, a typical element, I could put a student. So all students are the thing here, like maybe I should say Liberty students. LU student went to Convo. So this would be the set, so the condition goes over here, the typical element goes over here. That's what this notation means. So like to be more pedantic, I could say x a real number such that x not equal to 4, but yeah.
How would you write that in interval notation?
This one?
Yeah.
Oh. All right. Minus infinity to minus quarter, unioned with minus a quarter to 7, unioned with 7 to infinity. Like that.
Okay.
Yeah.
So when we do it in set notation, do you care if we put the -4 or 7 first? And then
Oh, it doesn't matter. The order there doesn't matter. In contrast, well, the order here doesn't matter either. right? You could put this before that, like this set, but what you can't do is switch these numbers.
Yeah.
That's not allowed. Although that is a very popular mistake. Let's see here, example 14. So if math was run by consensus, it would be partially true. Let's see here, 15x squared. Unfortunately, though, math is thoroughly not postmodern. There's not your truth and my truth. There is just the truth. So math is pesky like that. So here we're asked to write the expression in its lowest terms. So what you do here, when we have addition in the numerator, we can just break it into two fractions. All right, so like the pattern is if you've got a plus b over c, hey, that's just a over c plus b over c, no worries. In contrast, if you have c over a plus b, it is not equal to c over a plus c over b. This, again, to quote my community college professor, this dog will not hunt. This es no bueno. No. I shouldn't even write it on the board. So, all right, so here we go. 15x squared over 5x squared plus 60x over 5x squared. Some of you are like, where did the second 5x squared come from? The answer is algebra. So 15 over 5 is 3. X squared over x squared, 1. So we get 3 for the first term. 60 over 5 is 12. X over x squared is 1 over x. So we get plus 12 over x. There you go. Well, now your book wants the answer as 3x plus 12 over x. So, I mean, you could also do that. If you want to keep an x, I will take either of these as answers on the test. To answer your question, yes?
I can't really see this in my head, so can you write out the second one? Sorry.
That one, where this came from?
Yeah.
Sure, it's like this. So 15x squared plus 60x over 5x squared. So what he's doing is he's factoring out like 15. So I got 15 and I got an x. I can factor out 15x, and what's left over is x plus 4, right? And then down here I've got what? I've got 5x squared, right? And then I can simplify that. I can say, well, 15 over 5 is 3, and I can get rid of, I can cancel the x squared with the x up here. That leaves me an x. And then if I multiply this through, that gets me to the book's answer. So if I had my druthers, the book would also accept this as an acceptable answer to this homework problem. By not accepting this as an acceptable answer to this homework problem, it kind of irks me. Because I would certainly think both of them are correct answers to the test. I mean, either way, you have meaningfully simplified this rational expression, showing that you understand the laws of algebra. Yeah?
Isn't the x supposed to be -1 for when you subtract 1 minus 2? Why don't you just get regular like x under the example 14? Like for 12 over x, why is it not -1?
Well, it's to the -1 power because it's in the denominator. Like if I were to write 1 over x as I could write it like this, you know. But the minus you're thinking of, it's an exponent. It's not like out front. See here. So next example here, I'll move on to the middle board if I can find my eraser. How do you divide rational expressions? If I have a over b divided by c over d, how's that work? The way to do it is a over b times d over c, right? Or another way to look at this, if we have a over b divided by c over d, right? We can rewrite that as a d over bc. So if we have fractions divided by fractions, the denominator of the numerator becomes the numerator of the denominator, and vice versa. Like, so like example 15 here, I have 18 y to the 8th over 2y cubed divided by 81y over 6y cubed. How do I do that? So, yeah, we have 18y to the 8th over 2y cubed times 6y cubed over 81y. So to divide, you multiply by the reciprocal is what I'm telling you. And then we just need to cancel like terms, yeah? So there's some easy picking, some like easy things here. I've got a y cubed here and a y cubed there, so just cancel those out, right? I've got this y here. Let me show you a notation. So you can go cancel like this, and then take this 8 and replace it with a 7. See, because y to the 8th divided by y is y to the 7th. And then what am I left with? I'm left with 18 times 6 over 2 times 81. Now, this gives me, I've got 18 over 2 is 9, right? So I've got 9 y to the 7th times 6 over 81. But what is 81? 81 is 9 times 9, right? So 9 over 81 is just 1 over 9. We've got 6 over 9 y to the 7th. So the answer is 2/3 y to the 7th. All right. Yeah.
So you got the other 9 from the 81, right? Times.
Yeah, 81. So like 9 over 81 is 9 over 9 times 9. Cool. Okay, so listen, we've got a little bit more on rational expressions to do next class, but we're almost done with it. The part we needed to do next is like how to combine, let's see here, like we have, what I'm trying to tell you is we haven't done a problem, like we're basically up to number 30 in the homework. So like I'll start on a problem like number 31 and 33 next time, but I don't want to hurry those, so I'm going to leave it to next class. Yeah. Thanks, guys.